Hi there, Rachel Sherman here, and if you've made it this far in the series, this is going to be our last video on the Excel demo for students taking my course. Now, as you may recall from our last video when we had taken our samples and set them up for confidence intervals, once you finished filling it in, you would have looked at the coefficient of variation for each sample. In order to hypothesis test here, there's going to be a couple of things you need to do. First is take a look throughout each of your samples, and this is going to be the same process you do for your samples of 30 as you do for 5, and look to see which one you feel like is the best representation of whatever set of data that you're trying to compare it to. Usually you want to look for the highest consistency, and as we know about coefficient of variation, the lower the percentage, the higher the consistency. So for the next part of this project with hypothesis testing, you could choose whichever you wish, but for this one, I'm going to go ahead and take our sample number 3 of size 30, just because it has the most consistency in the data. Now, you could choose to pick something else if you're trying to prove a different point about how data can be skewed, and you can kind of twist it to say what you wish, although it's not the not necessarily the most ethical approach, but again, the point of the project is just to see how you can apply these different techniques, and the next one we're going to be doing this for is hypothesis testing. So what I'm going to do here is go ahead and take my sample 3 and use this one to demo how to conduct hypothesis testing for one sample means in Excel. Now I've already gone ahead and copied this set of data and pasted it into my hypothesis testing page and found the mean for it. What we're going to be doing is filling out our hypotheses, determining a significance level that's appropriate, using Excel to crunch the p-value for us, and then making our decision. Often this box will also be adding in some information about what this might mean with our data. So as you may recall if you've watched this series in full, the set of data that we found is related to physical inactivity in adults in the US. Now, specifically, this data that we've collected is based on 2019, and what I've done is I've gone back and found, in this case from the same website, however, it's not a requirement to use the same website, I found the mean inactivity level of adults in 2015 and thought that that would be a good comparison. So just to show you here, if we come down to the bottom of the list, we have a mean of 22.6. So in other words, it's 22.6 out of every 100 adults are physically inactive according to the data collection that they did. That value, depending on what kind of data you're finding, you may have to go search elsewhere, and bear in mind that your comparison value is completely up to you to decide. If you were able to find data from, let's say, maybe something comparable, it doesn't necessarily have to be years before. It could be a comparable procedure or something of that nature. Again, it's not necessarily about a time change. It's just trying to see if there is some type of difference. And being that in this Stat 1 course we only cover one sample testing, you're going to learn how to apply one sample testing here. Now, just as a disclaimer, this is not the end-all be-all. There are other types of hypothesis testing that can be done, but again, for purposes of the Stats 1 course, if you're my student, this is what we're learning. We learn one sample testing, so I'm going to show you how to apply that using Excel. Whatever comparison value that you have, you're going to start by plugging it into the comparison mean list. So essentially what I'm doing is treating this as the population mean, and I'm curious to see, has there been some type of change over time, maybe an increase, maybe a decrease, and we can investigate that a little further momentarily. So I'm going to go ahead and enter that down my list. Now, essentially what we're doing here is we have to trick Excel into hypothesis testing one mean for us since it doesn't have the capabilities to do one sample testing, but that's not a problem. The first step is to enter that comparison mean down your list. Your null and alternative hypothesis is going to be completely dependent on your data. Let's just say that I'm curious to see, has there been a change over time from 2015, which is here, to 2019, which is in our first list. So that would require us to do a two-sample hypothesis test. So in other words, our null hypothesis is that the mean is equal to 22.6. The alternative hypothesis is that mu is not equal to 22.6. Depending on the data that you've collected, you could determine if it feels directional, in which case that's fine. You can do a one-tailed test for direction. Again, it's entirely up to you, dependent on your data, how you set this up. What we'll do is just a 0.05 significance level. It's pretty standard unless you're dealing with life or death, in which case you want to up that as much as possible in terms of the significance. So you might use a 1% significance level, or even smaller than that if it is very extreme. Here's where the actual stat stuff in Excel comes in, and that's for your p-value. Excel is structured so that it generates a p-value for you. We're not going into using data analysis toolpack. We're just covering very basic hypothesis testing here. So we have our hypotheses set up. We've chosen our significance level, alpha, and we're going to find our p-value to do a comparison to. Now that I've selected the p-value box, I'm going to come up here to insert, under formulas, more functions, stat, and then down to t-test. So we're using a t-test because we're treating this as a sigma unknown situation. Array 1, you're going to go ahead and highlight all of the data from your sample. Array 2, although it seems kind of silly, you're selecting that list of values you put in as placeholder. The number of tails, since we're doing a equals not equals, this is two-tailed, so you enter the number 2. You'll see here it gives you little tooltips, and obviously you can only have either one-tailed testing or two-tailed testing. So for us, we're putting in 2. And for tricking Excel into doing this for us, this is where you always use type number 3. So that is two-sample unequal variance. If you're not using this example for one-sample testing, then I would advise that you move along and you look for another video. But if you're one of my students, or if you're looking for a way to learn how to conduct one-sample hypothesis testing using Excel, this is how you trick Excel into doing that for you. Okay, so now that this is all entered, we have to make a decision. Clearly our p-value is greater than alpha, which means that we fail to reject our null hypothesis. And while it would be great if we could stop there, the whole purpose of this is to make some decisions about it. So if we look at the data from 2015, which is on the right, to 2019, which was on the left, we can see that the means really are not that far apart. It went from 22.6 adults per 100 to just about 23 adults, right? So less than half a person difference between these. So our information we have here, our hypothesis test with a sample of 30, which is quite a reasonable size, is suggesting that there has not been much change at all from 2015 to 2019. So this box, you'll see I've added just the source of where my comparison value came from and any notes to myself. And then below that, I would enter, we can see that there has not been a drastic change over time between 2015 and 2019 in physical inactivity in adults per 100. And then of course, take a few moments, reflect, and add anything else as necessary here. If you're taking this course and you are going to be doing this again, you'll see that you'll conduct that hypothesis test for a sample of 5, and just like you did with your sample of 30, you get to choose amongst your 3 which you feel would be the most appropriate to do hypothesis testing for. Thanks for watching.